Hi, I'm Patrick, and I'm a security training engineer with Palo Alto Networks. My colleague Luke, who you'll meet in a moment, is a systems engineer with Palo Alto Networks. Together, we are the new hosts of Learning Happy Hour. So, as we ramp up our new episodes, we decided to get together over video conference and discuss an important topic: DNS. DNS attacks increase exponentially every year, and not everyone understands just how vulnerable they can be. I think many of us picture an attacker using DNS to redirect traffic from going to a legitimate destination to a malicious one, kind of like the coyote changing a road sign to redirect the roadrunner. But DNS is wide open for attackers, and the attacks often succeed because security teams lack basic visibility into how threats use DNS to maintain control of infected devices or steal data. The Palo Alto Network's firewall has specific features to protect against DNS attacks. The DNS service can predict and block new malicious domains, neutralize DNS tunneling, and simplify security with automation. To learn more about this and other methods, watch episode 13 of the Learning Happy Hour. Our focus today is different. Ours is more of a public service announcement about simple steps an organization can take to reduce their attack surface in DNS. I hope you enjoy it. Okay, so we are trying to thwart email domain spoofing with DNS records. So, since this is not an area of my expertise, my questions are going to be real. So, what are we trying to do here?
Awesome. So to cue this up, I've had this conversation actually at a few different security conferences, and the attendees actually got some value out of it. So we thought it would be a good topic of conversation for the Learning Happy Hour. Not necessarily pertaining to Palo Alto Networks products per se, but some of our subscriptions can help basically when a user clicks a link inside of an email message. But this is more around the actual DNS records that are published for your organization. So to start it off, public service announcement would be for your domain ownership, right? So when you go out and register domains, you have to do so at a registrar. And to access those domains, you have to log in. So my number one recommendation is to get multi-factor authentication on that portal and then understand who is actually accessing that portal and managing your domains. Some organizations will have not just one domain, but many domains, trademarks, that type of thing. So the next critical piece would be renewing those domains. You don't want to lose control of those domains. If someone picks that up and uses it against you, that's not good. These domains typically expire every 12 months. You can renew them for longer depending on the top level domain. .com, .org, they all have different rules. The third critical piece of this public service announcement is domain typos, otherwise known as domain typo squatting. Typically, what will happen is users will get an email that will appear to be the organization, but there's a typo, right?
Right.
You want to understand which domains exist that were either available or are already registered, and if they're interacting with your organization. Those are the three areas that I always harp on. I would say multi-factor authentication is a must. You don't want someone calling the registrar, tricking, getting passwords reset, guessing passwords. If you have a password that is understood by a lot of administrators, they leave the company. It's just an all-around bad idea. I'm preaching to the choir here, but at least get multi-factor authentication and understand who's accessing your domains.
Okay. So when we talk about squatting, I mean, that was always a problem that, early on when people weren't savvy, somebody would, forward-thinking person would grab, Nike.com or something and then hold it ransom, right? But that's been sort of done away with. Now we've got the problem with the typo squatting where it's just close enough that someone may not quite recognize the fact that it's not spelled right. And so what kind of things could you do with that? What are the security risks behind that?
Well, the first thing I would mention is what I did when I was in the field as a security analyst for a large organization was I actually there's some Python scripts out there, there's tools out there you can type in your legitimate domain. It It does basically leet speak and tells you every possible squat available under the sun, and then basically put that in an external dynamic list, feed that to your firewall, and prevent DNS from even resolving. That was one thing that I did. Cool. It's very cost prohibitive to actually go out and buy and register all those domains, because like I mentioned, you have to renew them every year. If it's even $10, you know, times thousands, it's a lot of money. It's a big investment. So typically there's organizations out there that do brand protection that will actually check for you. But user education is obviously one of them, but we're going to get into some of this with the DNS preventative measures that we're going to kind of overview.
All right, well, let's get into it then.
Yeah, so let's hop right into it. So basically, as a security analyst, you get tickets that arrive. You start looking into email, right? Someone says, hey, I received this email from the CEO. It doesn't look legit. Can you please take a look at it? I wanted to highlight a few things. So on this slide here, it's from Patrick, but it's not really from Patrick. Basically, or it's to Patrick rather. It's from a high-level executive or the government or someone who's trying to basically trick the user into clicking a link or replying back. So there's three different areas that we wanted to mention here. First one would be typo squatting, as we're talking about. If a typo squat is used, that's going to be hard to prevent because there's really no measure around validating where it came from, because it's a legitimate domain. Someone actually went out there and registered that domain. So unless you're out there actively looking for it, you're not going to know unless you're doing, like I mentioned, the external dynamic lists around if a user clicked a link embedded in the email that it wouldn't actually resolve, something like that. But domain,
otherwise it's just legitimate, right? I mean, it's
correct. Yeah, domain typo squatting is a legitimate tactic because it's a legitimate domain that you would receive from any other organization, right?
Exactly, right. Okay.
Yeah, so really it's just understanding what exists today, and if a new domain is registered, what to do with that. That's why building these external dynamic lists and just preventing users from ever visiting those domains, and also providing that list to your email filtering tool would help, because that way it's never going to come in, it's never going to go out. If users receive emails with that domain typo squat in a link, they're not going to be able to click it because it's going to get sinkhole.
Yeah, keeps it official, right? So
yeah. The second area would be spoofing a legitimate user and not expecting a response. So if you look at the SMTP header here I have on the screen, the from field, you can actually spoof that. And a lot of people don't understand that. What that means is I can actually put the CEO's name or a high-level manager or someone, or government, whatever, and it's known as the from header, right? So that's actually going to show up in your email client as a, John Smith or whoever, right? When the user replies back and they start interacting with this user, it's actually going to show up as that person. They're not going to really know that they're communicating with someone unless they actually look at the header. So this is RFC 5322, and that's known as the from header. And that can be spoofed. There's really nothing you can do. I can set up an email server today, start sending email from anybody I want.
Right. And
then it's a Patrick. You're going to receive it.
That's the thing, I guess, is that the average user isn't, they're just not going to be savvy enough to go in and actually, verify this. They're going to see it and take it at face value. And that's
correct. Exactly.
That's always been the problem with spoofing, is that it's so easy to do and most people aren't going to check, so.
Correct. So this is where our first DNS record type comes into play. It's SPF, and as you can see, RFC 5321 there, the mail from. What I could do is actually send an email, spoof the from header, but the mail from, the 5321, I actually own that domain, and I can actually issue legitimate SPF records for that domain. It'll actually pass. So what that means is I could spoof a legitimate user.
Okay. It's
going to pass SPF. So it's actually going to arrive at the inbox, and I'm not expecting a response in this scenario. I'm hoping the user clicks a link inside the body, and that's where your firewall would help.
So I could send it from the admin of your company or the IT at whatever at your company, and then make someone think, oh, this is IT needs me to click this, and
Yeah, and since
put in your credentials or whatever they're asking for.
exactly, and that's where your firewall would help, right?
Right.
The third area is the reply to field. Basically,
Okay.
what this does is I could send an email and include a reply to in the header. When the user clicks reply, it actually replies to a different email address. This is a third tactic. This is expecting a response. Hey, quickly respond back, please. They open up communication. Now it seems legit. Now the user's more adept to actually follow, a link or something like that. So typo squatting, pretty hard to thwart that. The spoofing legitimate user, that's I would say one of the most prevalent out there, because you get a ticket in, hey, the CEO asked for, pay stubs. You look at the header, it has the CEO's email from the from field, but if you look at the return path, the mail from, it's actually a different domain. And you're like, how is this possible? So SMTP wasn't built for security, and this is kind of showing that, right? So how do we protect against this stuff? So SPF was put into place to allow administrators to publish a DNS record, a TXT record, that shows the source of email from the domain. As you can see here, teeters.family, I actually own this domain, and I have a TXT record published in my DNS. And if you look at the syntax, it starts out with v equals SPF1. That's the version. So if we ever get to SPF2, that's where that would go. After that is MX. What that means is it's referring to the MX record of teeters.family. So MX record is where mail is sent to. So if I'm sending and receiving from the same source, that's a simple entry.
Okay.
If I have a email server in my DMZ that I'm also sending email for teeters.family, that's where I can include my DMZ block or the actual IP of that server. And the final is the include tag. If I'm using a marketing tool to send email on behalf of teeters.family, I can include their email servers as well as a legitimate source. So as you can see, under include, I have spf.marketing.com. So if you actually did a DNS query against that for TXT, there would be another TXT record, and there could be a ton of different IP blocks, right, that I'm not going to keep up with because they constantly make changes to their infrastructure. One thing to note is you can only go 10 queries deep on this.
Okay.
So if there are tools out there that you can run against your SPF record to understand where you sit and if you have any room to add more. The final ending for this is the -all. Basically what that means is if email arrived and it wasn't at any of these sources, the -all means hard fail. That means please reject. If you have a tilde-all, it's a soft fail, basically referencing spam. So any thoughts, opinions around what I just said?
Well, I was just thinking, so you're basically creating a almost like a whitelist or something of that nature of servers that can send, right? Does that sound about right?
Yep. And it's published in DNS. So that's why I showed the actual record, right? If you actually do a dig txt teeters.family, it'll actually spit back a response.
So, I mean, this would keep, I guess, people, not being able to alter emails in transit, right? Because you're basically saying what servers are legitimate, what are, and so they can't just go somewhere and be changed and sent. I mean, or is that even a possibility?
So that's a possibility with the next DNS record type.
Oh, okay.
So SPF is basically the sender policy framework. This is basically showing where mail should source from. If it's not from here, it's not from this domain.
Okay, so
this needs to be kept up on
the path, where it can come from, and that's it. It's just locking it down to specific servers. Okay.
Yes, very basic, right? This is very basic. This is basically saying, hey, this is where mail should come from, and that's that.
Okay, right. Well, that makes sense. All right.
Right. So moving on, if we want to validate that it wasn't altered in transit, This is where the domain keys identified mail comes in, otherwise known as DKIM.
Okay.
So to wrap your mind around this, when you send the email, okay, you just legitimize the source of the email, but what about the content of the email message? What Dekum allows you to do is actually hash the email as it leaves. And once it arrives, the recipient can actually query DNS and check the hash output to verify that the email was not altered in transit. As you can see in my example, I have selector. What that means is you could have multiple keys. So if I'm sending email from a SaaS provider, I can issue a key pair, private public key pair. Private key stays on the SaaS tool,
Okay.
but I go ahead and publish the public record in a DNS TXT record. So as you can see, the V equals DKIM1, very similar to SPF1, as we just saw.
Right.
But as you can see, the P tag there, that's where you put the public key.
Okay. So it's similar to like certificate, authorities, right? The public and private keys. We're doing it for email then.
Exactly. So as you can see though, selector, let's say I had a selector 1, selector 2, selector 3, I could actually have multiple key pairs depending on what service the email is coming from. So I'm saying, hey, expect mail from my SaaS service, but also expect mail from my marketing tool, and I want them to hash it as well. So that's where the selector value comes into play.
Okay.
As you can see, it's a dot, there's an underscore domain key, dot, then your domain. So in this case, tutors.family is another example for my domain that I own.
Right. Okay.
Right. So this is integrity, right? This is validating that the email received was the email that was sent using a DNS record. This is very important because you don't want someone to alter the email, and once it arrives, now they're clicking links that they shouldn't be.
Right.
So this is another tool that can be used with DNS. To wrap this together, there is the domain-based message authentication reporting and conformance, otherwise known as Demark. Mouthful, a lot of That's a pretty long acronym. But again, as you can see, it's a TXT record. So this is the third TXT record, which was free, by the way, that you can publish in your DNS to get security, right? So as you can see in my example, it's very similar to SPF and DKIM as far as the actual record looks like, underscore DMARC dot your domain. And then the value of it, right? Version equals DMARC1, very similar to SPF and DKIM. How DMARC comes into play is, okay, I just told everyone where mail should come from, my SaaS services, my marketing services, my DMZ, everything looks good. Let's hard fail that. I'm issuing multiple selectors, multiple key pairs. I'm hashing all the mail that's leaving my domain from my DMZ, from my SaaS services, from my marketing services. It arrives at the recipient, they check it, everything checks out, great. Well, how do I understand what my posture is today, tomorrow, next month? This is where DMARC allows the administrator to actually report back to the sender and also receive reports from recipients on if those SPF and DKIM records are passing.
Okay.
So the question I have for you is, how would you tell your senior executives at your company today that all email is sourced legitimately, right? So what I mean by that is, if someone spun a server up and started sending email on behalf of your domain, how would you know unless a customer forwarded it to you and said, hey, was this you? I got this funny email.
Yeah.
How would you know?
Okay, I see what you're saying. So so this is a way to be able to verify that information without having it to be something that is, volunteered to you, like you just described.
Yeah, automating the reports, automating the posture of your domain, right?
So this is this a service that you would have someone do for you? I mean, how would you access this information like that?
So you start out by issuing SPF and DKIM, and then you issue a DMARC policy. Again, this is just the third DNS TXT record issued.
Right.
And as you can see, if you walk along the actual output of my example there, P is the policy. So I have mine set to reject. So what that means is if FPF and SPF and Dekum fail, reject the email. I'm telling other organizations what to do with the email. With the SPF, as you remember, the dash all was hard fail and soft fail. Organizations don't necessarily have to respect that. They can say, I don't care if it's soft fail or hard fail. I'm going to take a lenient, posture and just accept it. Some organization will say, okay, if they're hard fail, let's just spam it or quarantine it.
Okay.
With Demark, I'm saying, hey, reject email that does not pass SPF Dekum. If it didn't come from me or the hash failed, straight up reject it. You could also get to a quarantine, and then there's also none. What none allows you to do is be in a monitor state and actually understand where the email is coming from that's failing before you start rejecting, right? You don't want to reject email that's legitimate.
Right. Okay.
So then the next question is, well, how do you receive these reports? What are you talking about reports? What do you mean reports? Where do I go to get these reports? My DNS server? No, that's not how that works.
Right.
So as you can see in my example, after the policy, I have a RUA and a RUF. So this is an email address that will receive the reports. Well, who sends the reports? The people who receive the email. So if I'm participating in Demark, like my email appliance is participating in Demark, as mail comes in, it's checking those Demark records. If it fails, my email appliance will actually send a Demark report to the sender domain. So if someone spoofs a domain, the domain that they spoofed is going to get a report that it didn't pass.
Okay.
Right. So this is a nice way of logging in every morning and seeing where mail's coming from. This is a sample report. So as a security analyst in the field, I would log in to a SaaS tool. There are many out there. And basically what they do is they give you an email address for your subscription. So in your TXT record here, they say, hey, for RUA and RUF, which is a forensic and an aggregated report, use this email address. It's for your organization. So as companies receive these reports to that SaaS tool, it'll actually dashboard this up for you. If you don't want to use a SaaS tool, there are open source tools out there, and you could actually supply your own inbox. What happens is the reports that you receive are in a .xml, so it's actually hard to parse. It's not really human readable. It's not easy to understand. You have to put those XML files into a tool to kind of see graphs and understand. So that's why using a SaaS service, the tool that we used, the tool that we used at my company was $20 a month. It's very inexpensive. It allows you to see, as you can see in this example here. So what do you think?
It automates the process. So you really just, once you set it, you can just check and make sure. And so versus having to go dig and,
Correct. Yeah. So what do you think about all this? I mean, SPF, Dekum, Demark, it seems kind of complicated. But if you really boil it down, right, it's 3 DNS TXT records.
Right.
It's going out, finding where mail should be coming from. It's going out, issuing those key pairs on the mail senders. So that's going to be your SaaS tool, your email server, right? That's where those keys are generated and stored. And then you just publish this in your DNS on the public internet. All right. So how do you feel about this? I mean, is this something that you would consider easy or hard or challenging? I mean, what do you think?
I think it comes down to it. It's just one of those areas that, you see more and more that, DNS is one of the biggest exploits out there in terms of security, but most of us sort of go, it's sort of auto magic, right? It just kind of works. And, you understand the records a little bit and, just this, hey, it has to be published. This is how, it comes in. But this actually, I think if you were to start talking about it, the initial reaction is sort of, oh, we're getting deep here. But then you realize it really is, it's three extra steps essentially to being able to lock down and really secure your email. So it actually is a very easy concept once you understand it. And I think pretty easy to implement once you understand it. I think just initially, most people probably don't dig that deep. But it is a serious, security issue when we're not doing these kind of things. So
yeah, if you go talk to any organization and go talk to their security staff, they're going to say email is a huge issue. They're getting tickets every day, a lot of email spam. If you go out and implement SPF, Dekum, Demark in a reject state, those tickets are going to dwindle pretty quick. If you go out, figure out every possible typo squat, get an external dynamic list on your Palo firewall, and start preventing that from even resolving, your tickets are going to drastically go down just by doing those two simple or, few simple steps, right?
Right.
Plus, it puts your organization at a much better posture for, not getting spoofed. You don't want your customers sending POs to the wrong email address or the wrong company. It's just a mess. So you want to do this not only to protect yourself from receiving bad emails from spoofed messages, but you also protect the organization from someone spoofing your domain to one of your customers, clients. It's just a good thing to do.
Well, if you think about it, I'm sorry, go ahead. What?
I was just going to say, so much that the government actually mandated this. The United States government actually mandated this. Department of Homeland Security mandated that Demark be implemented, I think, in 2018 for all .gov domains.
Okay, well, makes sense. Well, you think about it. I mean, when we talk about security, right? If you were a would-be attacker, which would you rather do? Have someone click a link and give you the information, or trick them into sending information to you, because they're not looking, or go write code and try to figure out exploits? I mean, this is why phishing is so prevalent. It's so easy.
It's so easy and it works.
Yeah, and so this kind of thing reduces that attack surface quite 100%. A bit. So 100%. Yeah, so this definitely would be. I mean, if it was me running a security, or the security of a company, this would be an absolute mandatory, step to take, because it is fairly easy to implement and makes things a lot easier. So,
I agree. Yeah. So here's a bonus. It's
important information to share.
So here's a bonus for you.
Okay.
So this is hot off the press. The brand indicators for message identification, Bimmy. This is if you have Demark fully implemented, which, you need to make sure everything is proper before you get to that reject state. If you're in a reject or a quarantine state, you can leverage this new Bimmy standard. I don't believe it's 100% fully official out there. I think it's in a beta. I think Yahoo and other large organizations are in on it, Google as well. But Bimmy is really interesting. Basically, what it allows organizations to do is include a logo when they send the email. So to the user, right, they receive the email in their inbox. Let's say SPF, Dekum, Demark, everything passed. The user has no idea. They just have an email in their inbox. All the tech stuff happened on the back end. It arrived at their inbox. They trust, hey, my organization's tools allowed this to hit my inbox. I'm going to open it. I'm going to click it. I'm going to see what's in there. So what the Bimmy standard allows you to do is include a logo for your organization on emails that pass the Demark standard. So it's taking it to that absolute cherry on top. Here's the Palo Alto Networks logo. It's in your inbox. Everything passed. And if you look at the example on my screen here, it's very similar to SPF, Dekum, Demark records. It's the version Bimmy 1. And then you have these tags. So the L equals is the location of my logo. So I host this on a public HTTPS protected website that's available. And that's how that works if you want to look at it from the deep end. So back to your point, I mean, once you get, it's easy to implement this, but as an organization, I would want my logo on all official email that was 100% validated as it sits in my user's inbox, because it gives the user more of a reason to click on it, right? Oh, I know this came from the company. Right.
Yeah.
So more on this soon. This is coming. This is something that's out there today, but I did some research and I'll demo this up and I'll test it myself, but this is something that's coming. I asked a few other security practitioners out there, hey, have you heard of Bimmy? And they say they don't know. So this is just more of a, public service announcement. So I thought it was interesting.
Well, I mean, it's obviously it's just a constant battle, right? It's always, somebody very smart comes up with a way to exploit, and we have to come up with a way to respond. So this is just.
Yeah. So it's more incentive actually to get to the Demark standard for the marketing team in this case, because everything we mentioned up till now was all tech backend security, right?
Right.
Now for the marketing team, I want to get my logo on my emails that I send to my customers. Well, to get there, you got to get through SPF, Dekum, Demark. it's almost an incentive to say, hey, look how compliant I am to these standards.
Yeah, no.
So the last, I think this would be the 5th DNS use case is certificate authority authorization. This is a new DNS record type that was introduced in 2017. I looked into it. It was actually an update to major OS providers, right?
Okay.
You apply the update, your server reboots, and now you have a new DNS record type that you never had before. A records, PTR records, TXT records, all these record types exist. CAA was introduced. Well, what's CAA? Well, to understand what CAA is, the certificate authorities that issue certificates on behalf of your domain. Let's talk about that for a minute.
Okay.
When you generate your key pair, the private key stays on the server. You take that public key to a certificate authority. You say, hey, can you sign this and give me a certificate so I can use it to host websites on the public internet? They say, yeah, I can do that for a fee, but also I want to understand that you own the domain you're requesting. So there's a process to doing that.
At least you hope they do that, right? So
they do that. That's part of the process.
Some have been caught not doing that, and that's been the
then they get revoked, right? And then no one trusts them. It gets removed from the trusted root certificate authority list of all major browsers and operating systems, and then it's a big mess, and anyone who used that certificate authority now has to scramble to generate new certificates. It's a mess.
Right.
So once you present your public key that you just generated, and you say, hey, can you sign this for my domain? They say, well, yes, pay me, and then I need to understand you own the domain. Typically, that process is they send you an email to a special inbox, and then you basically click a link and it validates you have ownership of the domain. The second method I've seen is actually issuing a TXT record with a crazy string. And once it's published out there, they actually do a query against your domain for that TXT record. If the string matches, they say, yep, you have control of the domain. And the third method I've seen is if a web administrator has access to the root website of the domain. So with the Teeters.family example, if I had a website, Teeters.family, they would say, all right, on the root of that site, put the key on an HTML file. I could put it there. They do a check. It's there. Good to go.
Gotcha.
This is all great and all, but the problem is if not rogue, but a web administrator wants to generate certificates without the security team knowing, they can do so because they have ownership of the web server. They can go out and issue these certificates. The security team doesn't know that these certificates even exist. And now they're tracing down, once it comes up for renewal, they don't even have access to the portal that was used to issue it. It's just one of those things where it's administratively a burden, but it's also a security concern.
Right.
When it comes to certificates.
Legitimate, but not, in that regard. So.
Yeah. So the reason why I wanted to go through that process is because they added the CAA record type to basically list out what certificate authorities can issue certificates on the behalf of your domain. So what that means is I own Teeters.family. I go to my DNS. I go ahead and create a CAA record. In my record, I actually say which certificate authorities can issue certificates. So if I removed in my example here, Let's Encrypt, and my web administrator went to issue a Let's Encrypt cert, it would actually not work because this is part of the process of issuing a certificate now. If a certificate authority is asked to issue a certificate, it actually first checks the CAA record of the domain to see if they're even on that list. If they're not on the list, they can't do it.
Okay.
They will actually send an email to what I provided on this example that even happened. Hey, someone requested I issue a certificate for your domain. I didn't do it. Here's the report.
Oh, cool. So yeah, so you can
more reports,
monitor it too. Yeah.
More reporting, right? So the final thing is wild card certs. So
yeah, I was looking at that issue wild down there. I was going to ask about that. So
yeah, so what this says is no certificate authorities can issue wildcard certificates. I don't want wildcard certificates for my domain, so I'm going to prevent it outright. So if a web admin gets lazy and just wants to do a star cert and use that cert across a bunch of different servers, you can prevent it by using, again, the CAA record type. So if you actually look at issuing this, it's, in this case, 4 lines. I have GoDaddy, Let's Encrypt, a IODEF, which is the email address of receiving those reports, and then my wildcard certificate lockdown. But you can tailor this to however you would like. If you only use a single certificate authority, multiple certificate authorities. How I got there as a security administrator was Google actually has a transparency report. You can go there and search domains, and they'll actually tell you every certificate they've ever seen. So if you are in control of your domain, but you don't understand all the certificates that have ever been issued for your domain, oh, do we use GoDaddy? Do we use DigiCert? You can actually search the transparency report. It'll tell you, hey, for this domain, we've seen DigiCert, we've seen GoDaddy, we've seen Let's Encrypt. So you might want to include all of those in your CA record to start.
Right. Okay. Well, that's cool. It means that, it gives you some control over that because, especially wildcards, that's when you hear about major breaches of, certain certificate authorities have been breached, it's always wildcards that get generated when someone, has access to that, because it makes it so easy to thwart the, PKI, to be honest. So in this area, with email, being able to say, look, this is all you get.
Exactly.
Yeah, it just locks it down. So that's really impressive.
Yeah. So as a security practitioner, right, you want to understand where mail's coming from. You want to validate that it's, not getting altered. You want to understand that report. Marketing wants to put their logo. You want to restrict who can issue certificates. All these things, right? Well, what tool do I buy? How do I do this? It's all DNS. This is why we want to have this conversation. DNS is very powerful. In my mind, you need to understand every record that's issued in your public zone, and you need to audit it at least once a quarter, because once people start getting access to that tool and start adding DNS records and you don't understand, well, what does this do? That's a bad position to be in. So back to the 3 steps, right? You need to understand who has access to your DNS, what records exist. You need to audit those. You need to understand that multi-factor authentication is in place to alter this, because once you have that locked down and when you start adding these DNS records, you're getting mail benefits, you're getting certificate benefits, you're getting marketing benefits. And if it gets past all of that, right, everything was put in place and now a user clicks the link, now that's where your other tools take flight, right? Your firewalls, your endpoint, your cloud technologies, all that comes into play there. So this is basically frontline, best practice, RFC level, in the weeds tech. And to be frank, I don't think we even really dug deep. This is basically showing examples and use cases. I've spent many hours reading into these technologies, and once you start getting into these tags, the nuances, a dot, a comma can really mess things up. So you really have to issue these records, run it through a few tests, understand what you're doing, and go from there. But once you're there, you can then sit back, sip on your coffee, read through your reports. When tickets come in for new email servers, when tickets come in for new certificates, it's all proper, it's all done the right way. It's not a question as to any of these areas.
All right. Well, that, it's knowledge is power, right? If you're going to try to protect your network, and by extension, your property, your assets, and your intellectual property, things like that, then you got to know what you're dealing with. And this, I think, is an area that many don't truly understand and makes them very vulnerable. So
I agree 100%. You have this conversation with administrators. DNS is one of those things, like you mentioned earlier, you set it, you forget it, you don't think about it. But if you actually crack it open and start reading through these different technologies and use cases, you can really get benefit from DNS. Wanted to clarify that this is not DNS resolution. This is authoritative DNS. This is stuff I control. This is stuff I'm publishing. This is what people query back and say, hey, does this check out? So, not to be confused with our DNS security subscription service, which basically analyzes all DNS traffic as it leaves the door. And if it shows up on our cloud prevention list, or it's a DGA or something like that, then it gets prevented on the firewall. This is more administrative, best practices and use cases. So with that, I don't have anything else for you guys. Thank you for tuning in. We appreciate you guys, and we'll be back with another video shortly. Thanks.
All right. Thank you. Thank you for watching this episode of Learning Happy Hour. At Palo Alto Networks, we are strong advocates of continuous learning, and we hope you are too. To continue learning about our fantastic products and services, you can attend one of our classes at one of our authorized training centers, or you can self-study through our digital e-learning courses. And if you like this episode of Learning Happy Hour, don't forget to like or subscribe and share with your friends. Thanks again for watching.